This is the first in a long sequence of recordings in which I plan to sketch the graphs of various polynomials. I aim to accomplish this by using information obtained from the formulae of the polynomials concerning axis intercepts, symmetry, vertex form, and in some cases using horizontal and vertical shifts. I will start relatively simple with quadratics and progress through various kinds of quadratic to cubics and quartics. So we will start with the following quadratic, which is already written in vertex form. Recall that vertex form is another way of saying that somewhere along the line someone has done a completion of the square on this quadratic and written it as a purely squared term with just a constant left. The advantage of this form is that we can immediately identify the coordinates of the vertex. In this case they are -1 and -3. We know that a quadratic formula gives rise to a graph which is a parabola. The parabola has either a maximum or a minimum. Whether a maximum or minimum, that will be the vertex. In this case, when we expand this quadratic, we will get x squared with a 2 at the front, and so 2x squared. 2 is positive, so that means it will be a parabola with a minimum at the vertex shown here. I now want to do two things. I want first to actually do the expansion of this quadratic and write it in the form ax squared plus bx plus c, and then I want to start drawing the graph. So let's start with the expansion by writing the square as a product of two brackets and now expanding out those brackets. I'll do this directly and collect terms as I go, so occasionally you might need to just stop the recording and check that you agree with what I've done. At the conclusion of this expansion, we are now able to identify the y-intercept immediately as y equals -1 when x equals 0. Let's start to mark some of these points on the graph. So that's the y-intercept, 0, -1, and the vertex at -1, -3. Like this. I've labelled the vertex V and also marked on that y-intercept on the axis. Since this is a parabola with a positive coefficient of x squared, we already noted that it will have the minimum at the vertex V, and therefore on each side it will head upwards, getting bigger and bigger as x goes far to the right or far to the left. Let's include that behavior. It looks like we can almost draw this graph now, but perhaps we should try to find out where the x-intercepts are. That means going back to the standard quadratic form, or alternatively to the completed square form. Let's go back and look at those. So there is the full standard quadratic form at the bottom in blue, and on the top in black the vertex form. We can use either of these to get the x-intercepts. In fact, the vertex form in black is halfway to having the quadratic formula. Let's use that vertex form and derive the quadratic formula result from that. That will give us the x-intercepts. So y equals 2x plus 1 squared minus 3. I'm going to write it out at the bottom. And to find the x-intercepts, I need to make that expression equal to 0. We can do some manipulation to find x. First bring the 3 to the right hand side, then divide by 2 and take square roots both sides. Like this. We're almost there. It just remains to take that 1 to the other side and turn it into -1. So these are the x-intercepts at -1 plus or minus the square root of 3/2. Notice equally spaced about that vertex coordinate x equals -1. If we want to make a reasonably accurate sketch, we could note that root of 3/2 is round about 1.2. So that'll give us coordinates at 0.2 and minus 2.2 approximately. Let's go back and put these on our graph, and then we can finish drawing the parabola. Here are the points, equally spaced about -1 on the axis, but now notice that I haven't really made a very good job of that beginning of the graph on the left. It looks like it would have been better if it had been a bit further to the left. Fortunately, I have the luxury of deleting it and redrawing it, so I'm going to do that. But it does give you a lesson that it pays to be careful and not to be too quick in starting these graphs off. So there is my finished parabola. That contains just about everything important I need to know about this graph. I'll stop there.